All right, rational exponents, our objective again, it's you will study and apply properties of exponents to rational exponents. Our introduction, when you have a times a times a times a and you multiply a as many times, then you get a to the n. The n represent how many times you multiply a. Say like here, if you have 5 square, that's mean we multiply 5 2 times. 5 times 5, there's 2 5, so the n here is 2. Or a lot of times you see in variable, if we multiply x times x, and then we get, because I multiply x 2 times, I get x squared. And here the a right here, it's my base, and the n is my exponent. So in this case, my x is my base and 2 is my exponent. If I have 5 to the 1/2 and x to the 3/4, what is my exponent for 5 to the 1/2? 5 to the 1/2, then my exponent will be, because 5 is my base, therefore the exponent is this portion, which is 1/2. And then for the second one, x to the 3/4, my base will be 3/4. I mean, not base, sorry, the exponent is 3/4. My base is x. So whatever raised to that power, so that power is called my exponent. Right? Here are some properties of exponent. When we have product with equal bases, meaning when you multiply two, product means multiply. So when you multiply two equal bases, mean they are the same, then you can, the property of exponents say that you can add their exponents. If you have power to a power, you have a to the m times to the n, then you can multiply the two power together, which is a to the m times n. If you have product to a power, meaning you have a product in your parentheses here raised to a power, then we need to take each term and raise it to that power. Quotient is divided. So when you want to quotients with equal bases, when we want to divide a to the m over a to the n, then you can subtract their exponent. And then quotient to a power, very similar to product to a power. When you divide a product, then have it to a power, then we need to take each terms or a variable and raise it to the quotients of that power. And then negative exponent, anytime you have something into a negative, you do not want to leave your answer in negative. You have to rewrite it as a positive. To do that, we're going to write it as a fraction, which is, or a reciprocal, which is 1 over a to the nth. When you rewrite it as a reciprocal, the negative goes away. So you have 1 over a to the nth. We're going to look at some example with this also. And then if you have an exponent of 0, like a to the 0, 10 to the 0, then it's equal to 1. And if you have exponents of 1, anything raised to the first power itself. That's why if we have 2 to the first power, we just write 2. We don't write the first power, because anything raised to a first power, it's that number or that variable itself. So let's look at the first example here. If I have product with equal bases, it said to multiply exponential expression with the same basis, keep the common base, and add the exponent. So here, let's consider the expression 2 to the third times 2 squared. And each term, as you can see, have a common base 2. So the expression can be simplified as this. As we looked at earlier, when we multiply two bases that are equal, we can add their exponents. So this, we can say this is 2 to the third plus 2, which is equal to 2 to the 3 plus 2 is 5. Then you can plug into the calculator, or we can say 2 times 2 times 2 times 2. 2 times 2 is 4, 4 times 2 is 8. Oh, I need one more. 2 times 2 is 4, 4 times 2 8, 8 times 2 is 16, 16 times 2 is 32. Therefore, this is 32. So again, when you multiply a product with equal bases, you can add their exponents. So we get 32 for the first one. Let's keep on going with the next one. When writing this, you don't have to, as you guys are taking note right now, you don't have to write all of this down, because like I explained, you can just write this down, or once we finish this, you can also go into Google Classroom, and this document will also be available in Google Classroom. All right, example 2, power to a power. To raise an exponential expression to another power, we keep the base. There's only one base this time, so keep the base and multiply the exponent. So let's consider the expression 2 to the third to the second power. So you have a power of to the third and then another power to the second. And the power to a power say that we can multiply our exponents together. So this is the same as 2 to the third times 2, which is equal to 2 to the 6. 2 to the 6 is equal to 64. And the property of exponents, I'm also going to write it down here. If you have a to the m to the n, that is the same as a to the m times n. And for the earlier one, let me write it down here. If you have a to the m times a to the n, then give me 1 second. This is equal to a to the m plus n. All right, so that's power to a power. Let's keep on going. If you have product of a power say that if you have a, b to the n, then we need to take each term, variable, or numbers and raise it to their power. So this is a to the n times b to the n. So for this example right here, to raise a product to a power, you keep the base and raise each factor to the power and multiply. So I'm going to take my 2, raise it to the 4th power, times x, raise it to the 4th power. 2 to the 4th power, 2 times 2 times 2 times 2 give me 16, and x to the 4th power is x to the 4th. So 16x to the 4th is my answer for that one. Right, let's keep on going with the next one. Quotient with equal bases. To divide power with the same base, keep the common base and subtract the exponents. When we yes, oops, sorry, yes. This one?
Yes.
All right, Then here, quotients, like I say, we going to it say let's simplify the expression. We're gonna keep the common base and subtract the exponent. We're gonna look at one with that, and then the other one with a fraction. So here is my letter A. If I have 2 to the 5th over 2 to the second, then we're gonna say this is 2 to the 5 minus 2. 5 minus 2 is 3, so this is 2 to the 3rd. And 2 times 2 times 2 to the 3rd power, I multiplied 2 3 times, and that gives me 8. Then for letter B, if I have 5 to the 3/2 over 5 to the 1/2, we can say this is 5 to the 3/2 minus 1/2. And 3/2 minus 1/2, or 1.5 minus 0.5 is 1. So this is 5 to the 1st power, and anything raised to the 1st power is the number itself. So this is 5 to the 1st power. Again, I'm going to write the properties over here when I have a to the m over a to the n. This is a to the m minus n. So we can subtract the exponent. All right, what if we have quotients to a power? To raise a quotients to a power, raise both the numerator base and the denominator base to the power. So let's apply the quotients to a power property to simplify the expression x over 3 to the 4th. So for this one, we need to raise each factor into the power, the exponent. So if I have x over 3 to the 4th, then we're going to take x to the 4th over 3 to the 4th. X to the 4th will still be x to the 4th because it's a variable. Oops. And then 3 to the 4th mean I multiply 3 4 times. 3 times 3 is 4. 3 times 3 is 9, sorry. 9 times 3 is 27, and 27 times 3 is 80, 81. So x to the 4th over 81. What if we have 8 over 27 to the 1/3? We're going to do the same thing. I'm going to take a to the 1/3 over 27 to the 1/3. So a to the 1/3 gives me, or we can rewrite it in a little bit. We're going to talk about rewriting this as a root. But a to the 3rd is 2. And then 27 to the 1/3, a to the 1/3, sorry, is 2, and 27 to the 1/3 is 3. Therefore, my answer is 2/3 for that one. All right, so quotients of a power. Let me go ahead and write this. This is if I have a over b to the nth, then I need to take a to the n over b to the n. And this is also available at earlier when we look at that. Then let's look at negative exponents. To simplify negative exponent, write the base as a reciprocal and then move the negative signs from the exponent. So if we have 2 to the negative 3, say that if I have a to a negative, I'm going to rewrite it as a reciprocal. So 1 over a, and then we're going to move the negative, and then I'll be left with a to the n. So the first example, if I have 2 to the negative 3rd, then I can rewrite this as 1 over 2 to the 3rd as a reciprocal. And then we know that 2 to the 3rd is 8. So this is 1 over 8. And then similarly with the next example, if I have 8 to the negative 1/3, then we can rewrite this as 1 over 8 to the 1/3. And then what is a to the 1/3? That is 2. So this is equal to 1/2. All right, let's continue on the last two. It's in addition to 6 properties we reviewed so far, there are properties you can use when working with non-zero numbers and the expression raised to the powers of 0 and 1. So any number raised to a power of 0 is equal to 1. So whether you have 2 to the 0, that's equal to 1. If you have 45ax raised to the 0, that is also equal to 1. But what we cannot do is that you cannot do 0 to the 0. 0 to 0 is undefined. So that's why it say this is working with a non-zero numbers. So 0, we cannot do 0 to another 0 power. And then the other one, so any number raised to a power of 1 is equal to the number itself. Like I mentioned earlier, 2 to the first power is 2. 0 to the first power, it's 0. For to the first power, you can write 0 for this one, but you can write 0 to a 0 power. 159, p to the first power, q to the first power will still be 159. P to the first power is p, q to the first power is q, so that is 159 p times q for that. All right, the properties of rational exponents. A rational exponent in the form of a to the 1 over n is defined as a to the 1 over n, which is equal to the nth root of a. So you may recall this. Let me go ahead and say the other one. The rational exponents in the form of a to the m over n is defined as a to the m over n, which is equal to nth root of a to the m. So here, my a is my base. And here, as we know, this is my exponent. This sign right here is called a radical. And then the nth here is called my index. So if you have a to the m over n, we can rewrite this as the nth root of a to the m. So I'm going to write down below here, we're going to look at a few of this. So here, if you have 5 to the 1/3, you can rewrite this as the cube root of 5. If you have 4 to the 1/5, we can rewrite it as the 5th root of 4. That's how we read it. And this is the one that we're so familiar with. If you have 3 to the 1/2, then we write it as the square root of 3. There is a 2 that it's understood to be there, but we usually don't write. But if you do have like to a third or fourth, fifth, then we usually write it. Say if we have right here, if you have 2 to the, I'll say 4/5, then here the 4 is my exponent. To rewrite it, the 5 is my index. So to rewrite it in this form, we're going to say 5 is my index. So we're going to go ahead and write my radical form. And then 2 is my base and 4 is my exponent. So you can rewrite 2 to the 4/5 as the 5th root of 4. We're going to look at a few more examples with that also. Alright, so here is a practice that I want you to do. So rewrite each of these numeric expression in radical form and solve for its root. Based on the result, arrange expression in ascending order. Ascending order means from smallest to the largest. So I want you to rewrite the numeric expression in radical form. So earlier we looked at a few more, so let's do this practice together. So earlier we looked at the how can we rewrite it as our like the nth, the root of it. So here, if I have 16 to the 1/4, then the top number is my exponent and the bottom number is my index. So if you remember that, then you will do just fine. Again, top number is my exponent, my denominator, the bottom number is my index. So I'm going to go ahead and do that for all of my terms here. This is my index. Again, that is my exponent and this is my index. Then we're going to here go ahead and rewrite this. My index is 4, so this is 4. Write my radical, and this is 16 to the first power. We can write to the first power. You don't have to write the 1, but it's the same thing. Again, 16 raised to the first power is 16, so you don't have to write the 1, but you can if you want to. For the second one, I have 64 to the 1/3. My index is 3. Write my radical signs, and this is 64. Then let's keep going. If I have 27, my index is 3 again of 27. And then lastly, square. This is square root of 25. We don't have to write the 2 if you don't want to, but if we can leave it like that, that's up to you. So what is the 4th root of 16? Another way to do this is that to think of a number. Okay, one number when I multiply 4 times, I get 2. So 2 times 2 times 2 times 2 give me 16. So if I multiply 2 4 times, I get 16. So this is 2. All right, one number when I multiply 3 times, I get 64. That will be 4. A number I multiply 3 times, I get 27. That will be 3. And then a number I multiply 2 times, I get 25. The number that I multiply by itself. So there will be a square root of 25. We're familiar with that one, that is 5. So to rewrite this as ascending order, the smallest number, which is 2, is 16 to 1/4. And then my next number 3, is 27 to 1/3. Our next number is number 4, which is 64 to 1/3. And then lastly, the last number 5 is 25 to 1/2. So from the smallest to largest. Alright, the next example, if I want to evaluate a to the 2/3, there are 2 ways to do this. So the first way is that if I want to evaluate a to the 2/3, again, this is my exponent and this is my index. So I'm going to rewrite this as 3 and then write my radical form. This is 8 square. So what I can do is for this first example, I'm going to go ahead and do the x squared, do what's on the inside first. So I'm going to take 8 square first. When I do that, 8 square give me 64, so cube root of 64. So what is the cube root of 64? Again, we look at this earlier. A number, when you multiply 3 times, you get 64. That is 4. Or if you plug it into your Desmo, you can see that also. And then another way to do that is if I have, again, my index is 3, I'm going to write my radical a, but this time I'm going to write my square outside of it. Now, what that means is that this time I want to multiply, no, not multiply, take the radical, take the root, the cube root of a first. So what is the cube root of a? What number, when I multiply 3 times, I get 8. 2 times 2 times 2 give me 8, so this is 2. Then I am left with a square. 2 square is 4. So whether you multiply, you square the a first or you take the radical first, either one, you're still going to end up with the same answer. So that is up to you on which way you want to do that first. All right, example 10. We look at these example before, but here are some more example or on how to do this. If I have 16 to the 1/2 times 16 to the 3/4, when I multiply two bases that are equal, meaning they are the same, then I can add their exponent. So this is 16 to the 1/2 plus 3/4. So that is equal to 16 to the, what is 1/2 plus 3/4? 1/2 plus 3/4 is 5/4. So this is 16/5/4. Then we can rewrite it as a radical form as my index, again, it's 4, so this is 4th of 16 to the 5th power. So what is 16 to the 5th power? Or we can also take the 4th root of 16. What is the 4th root of 16? That is 2. So 2 to the 5th power. 2 to the 5th power gives me 32. Or you can do 16 to the 5th power, which gives me, let me write this down right here for you guys. So a 4th root of 16 to the 4th power is 104, 8, 5, 7, 6. So 1,048,076. But when you take the 4th root of it, then you get the same answer, which is 32. All right, next example. If you have 2 to the 3rd to the 2nd power, when I have power to another power, my exponent property tells me that I can multiply them. So 2 to the 3/2 times 2. 3/2 times 2 is 3. So this is 2 to the 3rd power, which is 8. And then lastly, if I have 4x squared to the 1/2 power, this is product of a power, so I need to take each term and raise it to the power. So 4 to the 1/2 times x squared to the 1/2. I can rewrite it as a radical form. 4 to the 1/2, my index is 2, so this is a square root of 4 times, again, x squared to the 1/2, so my index is 2, so a square root of x squared. What is the square root of 4? That is 2. Square root of x squared is x. When I have a square root of x, which is the same as, or this is the same as, let me write it in a different color. This is the same as x to the 1/2 times 2, which is equal to x also. So 2x is my answer for that. All right, here is some practice that I want you to do. So practice 1, 2, 3, 4, 5, and 6. So I'm gonna give you guys some times to go ahead and copy number 1, 2, 3, and then 4, 5, and 6, and then I'll give you guys some times to finish it. Then we'll go over it. So go ahead and copy those down. Number 4, 5, and 6. Alright, what I want you guys to do now is that I'm going to give you guys about 5 minutes to do this. Then I'm going to go over it, and then I'll talk about the summary a little bit, and then your homework, it's down below here. So right now, I want you to go ahead and complete number...
I didn't finish copying.
Oh, sorry. This first part or the second part?
Second part.
Second part, okay, there you go. Alright, so... Alright guys, let's look at this. The first one, if I have x to the 1/2 times x to the 2/3, as we looked at earlier, when you multiply two equal bases, then we can add their exponent. So this is x to the 1/2 plus 2/3. So that is equal to 1/2 plus 2/3. Then we need to add 1/2 plus 2/3. And that gives us, I think, 7/6, because this will be, let me see real quick, 3, 6 plus 4, 6. So that will be x to the 7/6. You can leave it as that, or we can rewrite it as a radical form, which is, my index is 6, so 6 root of x to the 7th also. All right, letter number 2, if I have 8 y to the 6, to the 1/3 power, when I have a product of a power, then I need to raise each factor to the power. So this is 8 to the 1/3 times y to the 6 to the 1/3. So we can say this is 8 to the 1/3. I can rewrite that as a cube root of 8, my index is 3, times y to the 1/3. So I can do y to the power of another power. We can multiply that. So this is 6 times 1/3, which is equal cube root of 8 here is 2, because 2, when I multiply 2 3 times, I get 8. And then y, 6 to the 1/3, so this is 6 times 1/3, which gives me square, so 2. So 2y square is my answer for that. And then let's look at number 3. If I have -4 to the 1/2, then to rewrite it, we need to rewrite it as a reciprocal, which is 1/4 to the 1/2, which is equal to 1/1/2. Again, here my 2 is my index, so that is a square root of 4. 4 to the 1/2 is the same as a square root of 4, so that gives me 1/2. All right, number 4, if you have p to the 1/6 over p to the 2/3, this is dividing two equal bases, so we need to subtract our exponent. So 1/6 minus 2/3, and 1/6 minus 2/3 gives me, I think, -0.5. Yes, so this is p to the -1/2. Again, when I have p to the -1/3, we need to rewrite it as a reciprocal, 1 to the p, and then once you rewrite it as a reciprocal, the negatives goes away and your exponent is 1/2. Or lastly, we're going to rewrite this as the nth root, which is 1/square root of p. And then number 5, if you have x to the 6, y to the 4th, the product of x to the 6, y to the 4th raised to the 1/2, then we need to take each factor and raise it to the 1/2. So I should have x to the 6 raised to the 1/2 times y to the 4th raised to the 1/2. We can multiply this, or we can write it as a factor, but since it's a variable, we're going to say y to the 6 times 1/2. sorry, x, not y. X to the 6 times 1/2 times y to the 4 times 1/2 also. 6 times 1/2 gives me, that's 6 divided by 2 is 3, so x to the third. And then 4 times 1/2 is the same as 4 divided by 2, which is 2. So x to the third y squared is my answer for that. And then lastly, we have x to the 6, the quotient of x to the 6 over y to the third, both raised to the 2/3. So we're going to say this is x to the 6 to the 2/3 times y to the third to the 2/3. Again, because this is variable, I'm going to multiply my exponents together, which is 6 times 2/3, and then y of 3 times 2/3. All right, 6 times 2/3, that is x to the 4th. Y times 3 times 2/3 is y squared. So x to the 4th y squared. Good. All right, so here, let's look at the summary. So we look at the property of our exponents. When you multiply two bases that are equal, we add their exponent. When you add exponent, when we have a to the m to another power, power of another power, we have two powers, then we can multiply their exponent. If you have a product to a power, you have a and b, and then both raised to a power, then you need to raise each factor to that power n. Then if you have a to the m over a to the nth, then we can, when dividing two equal bases, we can subtract their exponent. Then similarly, if you have a quotient of a power, then you need to take each factor and raise it to the power. And then if we have a to the negative n, then we need to rewrite it as a reciprocal. Then once you write it as a reciprocal, the n goes away and you have a over n. Then we also look at here a to the 1 over n with your exponents over index. You can rewrite this as the nth root of a, or if you have m over n, then we can rewrite this as the nth root of a to the m. And then we also look at some example right here where you can either square the a first and then take the cube root, or you can take the cube root of a first and then square it, and then you should get the same answer. So that is all of the notes for today, and here is your homework. It's a match the expression with rational exponents to their simplified form. So on the left side is your simplified form, and here is your original expression. So you need to match each of these. So you can either draw arrows, or you can say, you can name this A, B, C, D, E, and name this 1, 2, 3, 4, 5, and then match your A, your numbers, and your alphabet, or you can draw arrows, or yes, any of those two ways. Then this, again, like I said earlier, the practice and the homework, it's available in Google Classroom, so you can view it from there, and you need to submit it either via Google Classroom or in my email.